हरिः कर्ता।
So now let's look into the second method in this, that's indexing with Boolean arrays. When we index arrays with arrays of indices, we are providing the list of indices to pick. That's what had happened in our previous sessions. Basically, we have indexed our arrays with arrays of indices. That means we provided the list of indices to pick the elements from the our array. That's one way we did it earlier. But now what we are going to do is we are going to index with Boolean indices. Boolean indices. So the approach is different. This is completely different. So we explicitly choose which items in the array we want and which ones we don't. So the most natural way one can think of for Boolean indexing is to use Boolean arrays that have the same shape as the original array. Let's directly put this into the practice. So this is a indexing with Boolean arrays. So let me check. A array name is A and np dot a range, and how many elements? I'll go with the 12 elements, and I want to reshape it to 3 comma 4. That's fine. 3 by 4 is absolutely fine, and that's it. So now what I'm gonna do is I want a new array, that's B. So that B equals to each all elements which are greater than 4. That's the condition, should be true, and all elements which are less than 4 inside the array A should be shown as a false. Let me execute that and let me show you print B, and yeah, this is what we got. So this is what the Boolean array, you got false or true, false, true, false, true. So now what we are going to do is we are going to index my A. So let me go up and click B. So here let me print A. Yeah, so I just want to index this array that you see on the screen marked with the Boolean array. Can you make out now? Can you understand? So now a B is a Boolean with a S shape. B, so B shape and A shape are same. Let me go up and click B, and A dot shape, it's a 3 by 4, and B dot shape, it's a 3 by 4. Both have the same shape. So B is a Boolean with the array A's shape. Clear? So now let's do indexing and see what's going to happen. A of B, here it is, and let me print A of B to make the things simple. Yeah, so it gave a row of items, a row of elements. That's what has been so 1D array with the selected elements. So 1D array, it's absolutely 1D array with selected elements, or true, 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 true. For example, 5, 6, 7, 8, 9, 10, 11, whichever all are true, or all has been indexed, all has been filtered. Clear? So that's one way of doing the things. And so the same property can be very useful in assignments. So let's do assignments using the same property. So what I'm gonna do here is, okay, assignments using booleans. So what I'm gonna do here is A of B and equals to 0. So wherever true comes inside this Boolean array, that should be replaced with the 0. That should be assigned with the 0. So wherever, so in that location, so now let me call for A, and you see that, and let me show you, and this exactly from this location to this place all has been changed to 0. So this is how you can even use this Boolean indexing for the assignment purpose also. Next, you can look at the following. Basically, one more example. We can see one more example to see how to use Boolean indexing to generate an image of the Mandelbrot set. Let's see that. Let's understand with the practical demonstration, or else it doesn't work. So, generate image, generate an image with the Mandelbrot set. Okay, so let's so anyway, numpy has been imported. I think matplotlib also imported. So let me cross check one more time. Import numpy as np, and import matplotlib dot okay, pyplot. This one I don't think we have imported. Matplotlib dot pyplot as plt. Okay, so now whatever is required, all the things has been imported, so no issue at all. So now let's begin our Mandelbrot. So let's define a Mandelbrot. The name we are going to give def. So Mandelbrot. So that's what the name I'm going to give to this function. So inside the function, I am going to give some parameters. The parameters are h, comma, w, comma, maxit. That's equals to 20. It's a default parameter. If you do not give this argument by default, it will take 20 values. And then r, another parameter that also has a default value. Okay, then colon. So what I want to return is a string. I just want to attach a string inside that. So it returns, this function returns an image of the Mandelbrot fractal of size. What is that size? H comma w. So this information should be provided, h comma w, whatever size that you give. Okay, this is our doc string. So the doc string has been attached. So now let's start writing the function. X is equals to np dot, this is our first array. So linspace I'm going to take here. So linspace, so from minus 2.5 to 1.5, positive 1.5, and 4 times h plus 1. H is our parameter that we have mentioned inside the function. And the second array is y, and np dot again linspace, and it's a minus 1.5 to 1.5, and this time it's 3 times. I'm gonna do w plus 1, and w is another parameter that we have mentioned inside our function. And then a comma b is equals to np dot, so mesh grid. You can see that another method, mesh grid. So we're taking the grid x comma y. So x comma y are the local variables that we have just defined on top. Sorry. Yeah. So after C, so now C is equals to a plus, sorry, a plus b times 1j. It's a complex number. So then z is equals to np dot zeros, like zeros like method, and capital C. So now I want div time. So I'm gonna write div time. Div time is equals to maxit that we have mentioned or as a parameter, a default parameter. It's 20 plus np dot zeros only. I just want to use zeros method, and z dot shape comma d type. It consists of a two arguments. D type is equals to int. So that's it. So most of the variables has been defined. So now let's use a for loop to iterate through. So for I in range of maxit, that's default value is 20. If you want to increase, you can increase. And then z is equals to z power of 2 plus c, capital C. And then diverge is equals to absolute. I want only positive value, so that's the reason I gave absolute is greater than r. And so that's what the last one will give you, who is diverging. And few more a piece of code to be written. That's a div now, one more variable. So this is equals to diverge, and condition, I'm writing a condition who is diverging now to know. So div time is equals to maxit. Then div time of indexing again. Div now, let me select div now is equals to, this is assignment, and z of diverge is equals to r. So now and finally get back to the initial indentation and return what I want to return. So I want to return a div time. That's it. And execute it. So I think there is no issue in code. So we haven't faced any errors. Let me plot this one. So plt.clf. So the figure size is 640 times 480 with 0 axis. So now let me show plot show the image. So the name of the image is Mandelbrot, and I want in a shape of 400 to 400, and execute it. And here is the magic. Fantastic, a very brilliant image, we got it. With slight modification you can get it. So what I'm going to do is, so I will take the same function. So plot imshow, I will use that. PLT is the module that we have imported. Imshow is the method that we are using from the PLT, and Mandelbrot is the function that we have just defined. So now what I'm gonna do is I'm gonna increase the size. So I'll put the 400 and 400, and I'll increase the maxit value to 23 and see what's going to happen. And we got the one more image with the different shape. You see that with this different and you see that inside you can see the inner circles, how they're varying. And let me go up and increase the r value to, let me increase the r value to here in this case, r value to 3. Yep, things have changed. Yeah, the radius has been increased and the look has been changed. So that's how you can generate the images even using this indexing. So that's why this is very important. The indexing is pretty much important. I hope you really like this image. Yeah, it's pretty cute, pretty fantastic image that we have generated. Just with the pure mathematics, we have generated this image with the pure mathematics, and then pure uh, indices and arrays. We have generated this image with the arrays. Yep, this is what the image that we have generated.